Good day, everyone. Welcome. I hope everyone's enjoying the content so far at the 2022 Smart Buildings Exchange. My name is Sokolowsky. I'm a senior project manager with the Smart Buildings Center here in Seattle, Washington. And I am excited to be here today to help facilitate a discussion about making existing buildings smarter. So we've had a lot of really rich content and discussion so far today. And so we'll expand that into specifically how do we find these benefits of smart building technology in existing buildings. And so just a couple of items of housekeeping. We are in a webinar session, which means you're muted as an attendee. But we do invite you to submit any questions or comments through the Q&A pane. We will be monitoring those throughout the session. And I've got Mark Willard from Smart Building Center helping moderate behind the scenes. He'll be helping me keep an eye on the Q&A pane so that we can get all of your questions answered, hopefully a little later in the session. We will take some time up front to do some short presentations, look at a couple of case studies and some real world examples of deployment in existing buildings. And then we'll have time for a discussion closer to the end of the session. So I just want to kind of give a little recap. Of course, we all have our definition of what is a smart building. Darlene this morning in her keynote session touched on this. Tends to be a broad spectrum of what people think makes a smart building. A simple definition might be a building that uses technology and data to maximize efficiency and safety and comfort for occupants. And by this definition, many existing buildings already have some aspect of smart in them. If they have a building automation system, maybe demand controlled ventilation, for example. And as we know, building controls have come a long way in a relatively short time, from completely manual processes to operating buildings to the invention of the thermostat, a very basic example of using data, even just one data point, to inform and automate processes of heating and cooling a building, for example. We've gotten to pneumatic controls and then electronic controls, and now we're in the age of direct digital controls. And I know in my career as a facility management and building operation professional, I've definitely seen technology come a long way. You know, implementing what was state of the art just a few years ago, and now is kind of old hat in some cases. And I know that we have many very seasoned professionals here in the room today who have probably also witnessed a good portion of that arc of the evolution of building controls and how we're operating buildings today. So what's next? Of course, it was pointed out in our earlier session on interoperability that controls for various building systems have evolved, but typically in their own silos within those systems. And so what is the next step in terms of efficiency? As with any product or industry, finding further efficiencies is the key to sustaining that. And this can often mean efficiencies of scale, but also finding ways to tackle more than one problem with one solution, right? This is where we really find the gems in terms of finding those efficiencies. So this is really where system integration and interoperability comes into play. And one analogy I like to look at is on the organization or company or community level. Of course, a company is stronger when different ideas and perspectives are shared, and within any community, this is the case. And so really buildings are no different. We can start to be looking at buildings as their own kind of living, breathing entities in a way. They seem more and more that way. And so, of course, the development of technology, including the Internet of Things devices, integrated systems, artificial intelligence. These really take interoperability and thus efficiency to the next level, with the result being the combined value greater than the sum of its parts, right? So, it makes, in concept, it makes sense if you already have lighting controls, occupancy controls for your lighting, why not use the same controls to operate your ventilation system or vice versa? Why not utilize technology like AI to help us detect faults, automatically adjust for different operating conditions, alert us to potential failures before they happen, preventing those catastrophic costs and headaches. And, of course, also an efficiently operated building is also, most times, also more comfortable and safe for its occupants, which then, of course, leads to higher efficiency and productivity. So we can't underestimate the value of that aspect as well. And so we're seeing, of course, a lot of this technology being implemented in designed into newer buildings coming online, as owners increasingly see the benefits, and not only are owners coming on board, but of course, we have a lot of different mandates and standards and codes coming down that are really kind of requiring it at this point, especially for new construction. But then what about our existing building stock? How can we implement these technologies in buildings that have already been built, often without the foresight of this design in mind, right? And so it all sounds really rosy on paper, but as we've already been hearing today, and we'll continue to hear about, there are a lot of challenges involved. These are complicated problems that can be solved and are being solved. And also, how does this evolution affect the workforce and the skills needed in the workforce? Of course, these technologies won't replace facility managers, building engineers, building operators, but these definitely change the skills they need. So that's what we'll focus on today, is the real world implications of implementing smart technology in existing buildings. And we have a really stellar lineup of panelists today, each coming from a slightly different role and perspective. So I think this will make for a really robust and rich discussion. So thank you everyone for joining us. I would like to just go ahead and give each panelist an opportunity to briefly introduce themselves, talk a little bit about how their current work intersects with this topic, and their own definition of what makes a building smart, because again, there's a wide spectrum there. So I'll go ahead. I'm just going to run down in alphabetical order by first name. Craig, we have Craig Engelbrecht, who is Vice President of Long Building Technologies, which is a service provider specializing in building automation, HVAC, and security solutions. Craig, go ahead and give us a brief intro.
Well, good afternoon, everyone. Thank you for joining. This is a great topic that has a lot of, I would say, rich history of individuals on this panel, and I'm sure yourselves as well. But with Long Building Technologies, we're a systems integrator that really focuses heavily on existing buildings, HVAC control, and physical security. We touch lighting control and OT networks, operational technology networks off of the IT. And so we've had a lot of experiences where when we start talking about what is the definition of smart buildings, it could be anywhere from some people define it as, hey, I have a building automation system, right? I've gone from pneumatic to DDC, and now I have data and I can do something with it and I can control it. Others, it can be a wide variety of different things where it's I want touchless access control, right? So I don't even have to touch anything. I want to have mobile credentials, so we don't have to even issue badges or cards. to other opportunities where they just want to have enhanced data analytics on top of this, the control system. From our perspective, all of those are smart buildings. It's really about what your mission and your value prop is that you want to do. But it really starts with data and system interoperability. And if you don't have the ability to get data, meaning you still have old pneumatic, or you don't have the ability to have those buildings and those systems talk to each other, then that's where it starts to break down. And so we'll talk a little bit more about some case studies and some different specific opportunities where those become smart buildings once you break those silos down.
Great, thanks, Craig. Yeah, I think it's important to keep in mind we're there's a broad spectrum of existing buildings out there, and really as professionals implementing these technologies, we need to meet building owners and operators where they are, right? So excited to hear a little more from you, Craig. I'll go on next to Joe Malaspino, a building engineer and facilities executive currently with Facilities Partners, which is a building engineering services provider. So go ahead and give us a little intro, Joe.
All right, thank you, Melissa. Welcome, everyone. My name is Joe Malaspino. I'm owner of Facilities Partners. We are a firm that provides building engineering services to owner direct managers and third-party property managers. Our responsibility is in the built environment is to make sure buildings are livable, safe, and meet all legal requirements of the owners and their tenants. We do not design, construct, or install. We are tasked with making the end product work. Smart building definition. When I think of smart buildings, I think of technology. The technology doesn't necessarily need to be new for it to qualify as smart in my definition. When I started in the industry, time clocks and programmable thermostats were smart. One of the first automated control systems I was part of, we installed in 1987, and it ran on an IBM 8088 with a 5 1/4 inch floppy and 2400 baud modem. And I think that the folks that have been around a while understand that that's pretty archaic nowadays. Although I think there's probably a couple still in use. For me, the smart buildings really took on a new meaning in 2001 when we started integrating the different systems and major components. It was at this time that IQ potential of smart buildings took a huge leap and things became more complicated. Fast forward 20 years and we are still working through the best way to integrate systems and effectively operate the technology that's in front of us. Looking forward to kind of the open panel discussion that we're going to have here and just more on our experiences. Thank you.
Great, thanks, Joe. Yeah, looking forward to hearing about some case study examples from you as well. And next I'll introduce Michael Grenier from Extensible Energy, which is a cloud-based intelligent energy control software. So go ahead and give us a little intro. Michael, welcome.
Thanks, Melissa. Yeah, well, like you said, Extensible Energy is a software company. We're really focused on, I would say, the climate and energy aspects of smart buildings, and the definition of smart building is huge, as Craig and Joe said. And we're really focused on what I would, well, you've kind of already mentioned it, right? The silos, the data, the interoperability. We're trying to solve the problem of creating a very low-cost solution that can apply to all buildings or almost any building. The hope here is that with a whole bunch of technology changes that have happened over the last 10 years, plus the changes in our, let's call it energy and policy environment, that you can take advantage of all the other reductions in technology cost and along with their sort of increasing performance and put them together in a new way that you get a better overall solution.
Yeah, I like that. That's an interesting concept of kind of putting the pieces together in a different way. It's, it gives a fresh new look and or a fresh new function, right? Functionality. So it's great. Thank you. And then lastly, but not least, I have Reid Powell here from MacDonald-Miller Facility Solutions. Reid is a smart building services professional with MacDonald-Miller, which is a design build mechanical contractor. So go ahead and introduce yourself a little further, Reid.
Thanks, Melissa. Yeah, as Joe said, welcome everybody. Super excited to be here. My name is Reid Powell. I work at MacDonald-Miller. We operate in the Pacific Northwest, so Washington, Oregon, and little parts of Idaho. Design, build, mechanical contractor, around 1,500 employees. So do everything from large new construction jobs to taking care of, single zoned buildings, right in your neck of the woods if you live in the Northwest. So pretty broad spectrum of expertise. Specifically, my job is to support a team of systems integrators, so people who work with control systems and cloud-based analytics platforms to get them to speak the same language, and then a team of data analysts who are supporting our technicians in the field. We have about 170 service technicians every day out there maintaining buildings, and so those analysts are supporting those techs with data as well as our clients. So depending on our clients' setup, they may have their own building engineers. We are feeding data to them so they can make data-driven decision-making, data-driven decisions. If it's just our techs in the buildings, then we're feeding that data straight to them. We have a decent amount of fun with smart buildings. It's been a cool, evolution really in the last 4 years has started to change how we can go to market with services. And so where we come at it is how do we ensure comfort in spaces, being an HVAC provider, a controls provider, how do we provide comfortable spaces, decrease downtime? So, Michael's talking about energy. I'm really excited to hear his case studies. We really have been coming at it from how do we change our service model? So a little bit of a different take down into specific pieces of equipment and the diagnostics you can pull there. So depending on where you're at in your learning journey with smart buildings, that's going to scream fault FDD, fault detection diagnostics. So we love that at MacDonald-Miller. Helps us do our jobs a little bit differently. And to that point, I'll hit I think Melissa, right, the definition of smart.
Yeah.
Before I get there, plug for MacDonald-Miller. We're hiring. If you're at this conference trying to get into the smart building space, I'm sure everyone on this call is also hiring. But if you're trying to get into this space, there's 5 great people here for you to go talk to and learn more and get involved because it's exploding. So that's pretty sweet. For me at MacDonald-Miller, I think this it's forced due to the breadth of our company with performing the construction and doing the controls is also analytics. Is any building, any smart building to me, it doesn't actually have anything to do with technology. Are you getting high tenant satisfaction? Is it easy to operate? Are people having ease of use? Is it easy to operate? And is it performing on its financial metrics? And the reason I rip away from the smart is when I'm sitting there with our special project salesperson, our controls salesperson, and our service salesperson, we're all thinking of how do we best support a client. It might be that they need to switch out a chiller and skip out on analytics and FDD. That could be where they're going to get their most bang for their buck. And if their metrics are comfort, clarity into the systems, and then providing a good financial return, because at the end of the day, buildings are about money in some certain aspect. So when it's hitting those 3 things, for me, then they're making smart investments, smart uses of those space. Cool.
Yeah, absolutely. Thank you. Really interesting, and I love your take on the the definition of a smart building. And again, a theme I'm hearing is meeting customers where they're at, meeting building owners where they're at, adapting to this ever-changing marketplace, ever-changing technology, and finding the right solution where we need them, right? And trying to make these integrations as simple as possible. And I also really appreciate your plug there, Reid, about the workforce. And I do want to get into a question about the workforce skill set, our opportunity with bringing up the next generation of folks in this industry. So we'll get into that in a little bit. First, I want to give an opportunity for you all to share some thoughts, do a little deeper dive. We've got a couple of case studies to look at. So first, I'll go ahead and turn the time over to Michael to share with us a case study demonstrating a successful smart technology deployment at an elementary school in California. So I'll go ahead and let you share your screen, Michael, and then we'll get into some other case studies, a joint project. Reid and Joe will talk a little together about what they've learned, and then we'll hear some real world examples from Craig as well. So take it away, Michael.
Okay. And you can see my shared screen.
We can
Awesome,
see
thanks.
your screen it's in the PowerPoint mode. I'm not sure if you want to put it into slideshow view or not. It's up to you.
Due to technical difficulties, we'll just do it the
We'll
old
just
school
leave
way.
it as, yeah, old school.
All right.
Sounds good. Sounds good.
All right. So, all right. Well, I'll spend just a few minutes trying to provide some context about what the software is doing so that hopefully it makes more sense in the case study and sort of the challenges that we were grappling with in the case study and why we found them, sort of significant. So Extensible, again, is a software company. We do have a small hardware component, but as much as possible, we're trying to stay away from touching hardware and leverage existing systems, IoT devices, smart thermostats, building management systems, and really provide a robust integration with those existing systems so that building owners can get as much value out of them as possible with as little CapEx as possible. So we set out to tackle the challenge of climate and energy management. And I think anybody's tried to manage a building before, they know, and they're trying to they have both keep their people comfortable goals and lower the bill goals. They understand the reality of the conflict between managing climate and managing energy and managing people personalities. And one of the problems that we find with a lot of the existing control solutions is that they operate in silos. And so when you have this trade-off between two different goals, you really need to have data from both and be optimizing from both in real time. And a lot of the existing systems don't, I think there was an earlier panel and there's a stat that an earlier panel where James Dice was on, and he has a white paper talking about how more than 85% of buildings don't have any controls at all. So those buildings, the control system is whoever put the button on the thermostat. And then of course you can go up from there to more sophisticated levels of control, right? With a full BMS and a whole team of people supporting it. But either way, you still have the same problem of managing two somewhat contradictory goals. And then another thing that's making this job harder is that our buildings are getting more complex. And so the operating profiles are changing and the number of systems you have to manage are changing. If you just think of the number of variables you have to track, those are starting to go up exponentially. And of course, the big ones are, as we start to transition, the electrification of heat from gas to electricity and install more heat pumps. That changes the electric load profile of the building quite significantly. And then EVs, of course, also do the same thing. And not every building is going to face the EV challenge, but in a lot of our building types, we do see that. And those tend to be schools, office, retail. So the last thing is, the way we get charged for power now is not the same as it used to be. It used to be, even just 10 years ago, most of your bill was determined by how much you used. So how many kilowatt hours went through the meter, but that's changed pretty dramatically in the last 5-10 years. And now we run across customer bills where as much as 70% has nothing to do with the volume of energy used. It has to do with when they use that power. And sometimes a single 15-minute period is what sets that 70% of the bill. So that's a whole new level of real-time challenge for people now who are trying to manage their bills along with their comfort. And we think that's a great thing for software to do. So how does it work, right? It's software. It needs to communicate with the building and the systems in the building. So if you don't have a BMS, for example, that's already that connection point, then we have a simple gateway that goes in the building. But what that gateway does is it's connecting to the basic, the key systems in the building, right? So we're looking at the HVAC system, we can look at lighting, we can connect to EV chargers, we can monitor the solar, you can look at the battery, and you can look at all these systems and pull in data, and we're pulling in data once a minute, every minute. And then we combine that with data you can get when you're a cloud-based solution, right? So your utility rates, and those can be static or real time. You can combine that with outside weather temperature, and you put that all into a big optimization engine that's running in AWS or some cloud service, and you use that powerful computing to crunch a lot of numbers, run a bunch of fancy math, right, and eventually spit out a control decision at the end. And you send that decision back down to the building and say, okay, turn this on, turn this off, throttle it up, throttle it down to get the desired result. So that's what DemandX is doing, right? It's pulling in those inputs, it's running through the model, it's sending a controlled decision. And if you're trying to optimize energy, of course, the biggest thing you need to manage right now is HVAC. And then after that, tends to be either lighting, and then quickly it becomes EV charging, or managing more sophisticated systems like predicting solar or managing battery. So we're doing this across a whole host of building types in a whole bunch of different climate zones. And Extensible has been around for a couple of years now, building its portfolio. But we got over 10,000 days of operations now, and generally speaking, the results across all the buildings, they vary, but we're seeing an average of 25% reductions in peak demand. We're seeing on average that comfort is either as good or better. All this because you have software which can keep up with all the different variables that you've got to keep in mind. And some examples of those savings, we're going to talk about the top two here in a minute. But generally we have overpromised we've not overpromised. We've over-delivered from what we've promised. And we hope to keep that up. One of the big reasons for that is as our software gets to work, it tends to improve over time, right? So we're using all the acronyms, right? Machine learning and AI and all of that. But as the software sort of it gets more operating history underneath it, it improves its ability to predict and control the building in a way that's optimal. So one of the reasons it's really hard to balance these competing demands is just the number of variables you have to consider and the time frame in which you have to consider them. So we talked about when mattering more than how much, and one of the reasons for that is something called demand charges. And demand charges are different than a volumetric charge. For those of you who don't know, it's the highest 15-minute peak that your building sets during the month times a rate. And what's different now is that number has gone up by a lot. It used to be a small percentage of the bill, now it's a large percentage. And so that one single spike, right, that might happen during a coffee break, that now is what you have to manage for. And that just becomes unpractical for a person to sit around their desk doing that all day long. So if you use software, you can predict these peaks, you can see them coming, right? You can model the behavior of the building, you can know the utility rates, and based on that, you can more intelligently dispatch effectively what the building systems are doing. And so the benefit of that, right, is that you move energy from one time frame to another, you lower the peaks, and you can avoid high time of use charge periods of the day. So what does that look like in a real building profile? Well, when you let software do the work, it comes up with some interesting solutions. And I like this particular day that I'm showing because it does some things that are counterintuitive. So for example, you'll see that the building load spikes sort of early in the morning. I think that's around 3 a.m. or 4 a.m. And that one really had our head scratching for a while because we did not expect that behavior. But what it turned out, it was that actually that was the cheapest time of day to add some heat into the building. And it would, because of the thermal properties, the insulation of the zone that it was heating, it knew that it could hold that temperature for a longer period of time. and avoid sort of doubling up the amount of energy that would happen at the normal startup time later in the day. And then the other interesting thing that the software can do, right, is react in real time to events or anomalies that happen in the building. In this case, it's a solar one. So in the middle of the day there, you can see that the yellow line drops off. And when that happens, normally the building load would spike, right? What you see at the utility meter, you would normally see the utility usage spike up, but instead the building actually drops. And what's happening there is the software is seeing or predicting the cloud passing over the solar array, realizing that it's going to set a spike, and then quickly starting to change the dispatch of the HVAC system, typically by raising set points for a period of time until the solar comes back. And so what looks like a big dip in the load profile there in the blue line would have actually been a really huge spike. So that's what we call the biggest mistake of the month avoided. And then that adds up over time, right? So software never sleeps, and it's basically picking up nickels and dimes every hour. And over the course of a month, and then over the course of a year, that really adds up. So this is an example of an office building in Colorado, and it's only over a 3-month period, but just a very, very simple regression analysis, just looking at the daily minimum temperatures and the peak demand. You can see that on average, the software is able to deliver a lower peak load from the building than what we just called human control, but what had been previously programmed in by the building engineers, which were, best in class, smart schedules, trying to take into account all the variables. But the challenge, of course, is every day is a little bit different, and the optimal run for every day, or in this case, the building had solar, how to react to those solar events is more of a real-time problem that software is best suited to handle. And so the other thing that the software does that we think is a benefit is it can actually hold temperatures a little bit more consistent. And a lot of times we see buildings with a profile like on the left where it doesn't really anticipate exactly when it needs to start up so that when people arrive at the building, it's comfortable. And this is from the same building in Colorado, cold winter mornings, but it would often undershoot, right? Start too late. And so people would show up in the first several hours that people are in the office, they're cold. And with predictive software, right, it can adjust to that day's temperatures in advance and change the schedule every day in advance and do that while also optimizing for energy. So let's talk about a case study. So this is a Central California public school system. There are a couple of different buildings, elementary schools, middle schools, where we started managing their buildings back in November. And so this is the latest and greatest data from them. So all these schools, the two things we were primarily controlling were HVAC and solar. And I'll clarify, we don't control the solar, right? We monitor, predict, and react to it. But we're looking to optimize what the solar electrons are being used for. We had a pretty big temperature range that we had to deal with. So everything from below freezing to boiling hot, that's Central Valley. Some of these schools were fairly complicated in terms of their building thermal profiles. So we would have, sort of the normal main building, and that may be concrete construction, but then we'd have lots of outbuildings, temporary facilities that have become permanent, tend to have really poor insulation. And so it was a challenge of managing all of these zones of very different thermal characteristics, but doing that to also minimize their energy spend. And then we needed to do this without CapEx, right? So this was, so one of the challenges was how do you optimize what you have, right? Rather than spending a whole bunch of money to make it better. So here's an example. I've cherry picked a couple of pictures because they help tell a story. And then, the bigger story is that this is happening sort of every day, every hour. But one of the challenges the school has, right, is how to intelligently dispatch its HVAC system on cold mornings. It's they've got all these different zones. They can try and set a smart schedule, right? They can try and set a staggered schedule, but like I was showing in one of those earlier slides, the challenge here was to make sure that each of those zones was at the target temperature at the time that staff or students arrived. And through predictive control, right, you're able to forecast the weather, know the thermal properties of the zone you're trying to control, and then you can use the software to calculate basically an optimized dispatch of the HVAC system. And here's the results, right? A lot of words, but the results that matter here is the peak demand, right? We were able to lower from 246 to 170. And that 30% reduction means thousands of dollars, or, in this case, for this particular utility bill for this school, right? That was more than $1,000 in savings that month. And then you have a similar challenge in hot days, and you get afternoon peaks. So this is, getting towards, this is August. You have some solar production during the day. The school is trying to keep up, but usually by the afternoon, when temperatures are really high and solar is starting to fall off, the solar is not offsetting the HVAC use anymore. And so if you can see that coming, right, you can learn to intelligently pre-cool the building while you have the solar, keeping the temperatures lower during that afternoon period when the solar is rolling off. No matter what, you're going to see the building energy use rise, but your goal is to not set the same peak. And so that's what this picture is trying to show, right? Is you can see the reshaped load profile. It stays much flatter over the course of the afternoon rather than climbing. We get another 25% reduction in peak load, and just that peak load, and we're not counting energy savings here. This is just KW or demand charge savings. Just that one day saved them over $1,000. So we had another challenge at this school. The teachers had negotiated the right to control the thermostats. And we were every building's a little different. We run into something like this every time. And one of the great things about software, of course, is it can be flexible. And so when we were informed of this requirement, we programmed basically a new feature into the system that allowed for what we call temporary manual override, which is a fancy way of saying that the teachers could go hit the button, put it to whatever temperature they wanted, which is fine by us. We'll optimize within whatever range is given to us. And in that temporary override, we would optimize during that period, right? The overall optimization of the entire facility, right? That became included in it. And then, but one of the benefits here, right, is that the facility management team still had remote visibility and control over that, right? If there were issues, they could see it and respond to it from wherever. The teacher felt like they had control and they got the temperature that they wanted. But then when that teacher left, the thermostat didn't stay at whatever, right? So if it was set at 68 degrees and then it was going to be out and occupied for the next 4 hours, it didn't need to be at 68 degrees anymore, chewing up energy. And so the benefit of the software, right, is that in that temporary override is you give people the control and visibility, but you still maintain the optimization because the software takes back over. And this is like a small vignette of building drift, right? So in a bigger building, we can think about a BMS, something gets changed, it doesn't get changed back. And all of that is just drift in the building settings and ultimately means waste, right? Wasted energy, wasted money, higher emissions. And so the benefit of the software, right, is preventing that drift from happening. It's like always bringing something back to the optimal. Another challenge we had was security. So the school had some unique security requirements. I think a lot of providers have a very similar solution, but I share this just to say that it is a very solvable solution, and I don't think anybody should be scared of it. We take an approach of basically just having a parallel communication structure where our signals go through their own VPN tunnel. They're all going through the same modem, but they're encrypted and secure from end to end. So nobody can get from sort of, let's call it our communication layer into the school's communication layer. So that protects the school's IT infrastructure and all their sensitive data. And here's the final results from those last, what's it been, seven months. So across 4 schools, net savings across the board. I don't remember the exact pricing at this school, but roughly speaking, the school is saving 2 to 3 times the monthly cost of the service. And that's our case study.
Fascinating. Really interesting result there. Thanks for sharing and for all the context that you also gave us. There are a couple of great questions for you there in the Q&A pane, Michael. I'm gonna let you go and type some answers to those if you can, just in the interest of time, so that we can get to the other presentations, and then we'll come back around, and if we have time, we can address those live. But thank you so much. It's good to hear also your take on the security issues, because I know that's a big, of course, a big fear for many folks considering these kinds of implementations. So, and I know, I think Craig is going to talk a little more about that as well, and his experience that there's security, not only in the networks, but tied in with the physical security systems for the building itself. So really valid point and concern. And it's nice to hear that you know, it's easily solvable. It's good to hear that. So next, I want to turn the time over to Reid and Joe. I think, let's see, Joe, you're going to go ahead first and share a little case study, and then I think you'll tag team with Reid. Is that correct? Share.
It's flipped, but we're good.
Okay.
We're gonna roll, and
okay.
You'll have to tell me if my screen does come up, because as soon as I hit share, my whole other monitor went black. So we're gonna go with
gotcha.
what we got here, and let me know if that goes. Can you guys see the screen?
Yep. Looks
Perfect.
Good. Yep.
Okay, so what I'm going to be talking about here today is King County Library Systems, a client of MacDonald-Miller's, and then Joe and I worked on a project a couple years ago, deploying some smart buildings options for a mutual client of ours. And so then Joe and I will be able to chat about what went well there. And so first, King County Library Systems, if you didn't know, if you're not from the Northwest, King County, fairly large county within the greater Seattle region. But specifically like up there in the top 5 largest library systems in the US. So they got tons and tons of buildings. They're serving a lot of clients, and they need to stay open. And so from a MacDonald-Miller footprint with King County Library Systems is we are their HVAC service provider, their controls service provider, as well as provide them with retrofits across many of their different sites. And in 2015, we said, hey, there's this cool thing with analytics we'd love to deploy to help you save energy. And we did that with a few case studies. So if you're looking as a customer trying to figure out where you want to go with smart buildings, a great place to do is like, can I pilot this on a building? Most likely, you know, in the day and age of 2022, that's going to be a paid pilot for you with your technology partner. But it's a great way to see, hey, is my organization ready for this? Is this the use case I'd like to have? So with King County, we deployed that system, and what we found is they had a decent amount of leaking valves in a couple facilities, things you do not see with the naked eye when you're coming through and servicing equipment. And so by finding those issues, replacing that equipment, being proactive with those changes before it totally broke, it was just not optimal. We were able to help with comfort and energy savings. The reason I would say King County is an early mover here is they have some mandates because of where they're at in their region and what they need to provide as a public entity. But if you think about public entities, something that they do, or often you'll find in their customer use type is their owners, occupiers, and operators of the facility. And so when you think of return on investment, they typically get to capture all three. Hey, I'm the owner, I put this in and you helped extend the useful life of my equipment. Cool, that's good money for them. I'm the occupier, you put this in and you lowered my energy bill or you increased my comfort. Wow, great, that's good for the tenant, that's good for the occupier. The operator, hey, I have more data at my fingertips to make informed decisions. I can prevent less fires, less issues in my buildings, and be proactive with my customers. And so one reason, again, King County was able to be an early mover is they get to capture all three of those benefits. Sometimes you see that as a split incentive in a different layout. The building types we're looking at with this customer is typically in that 20,000 to 80,000 square foot range. Some of those have smart IoT thermostats in them. Others have full-on building automation systems. What's been sustainable for us and for them is rolling about 5 buildings a year into an analytics platform for them. And so that's how we've been chunking away at it, keeping modern on their portfolio. We're just about to finish up here in this next year. What King County had the really fortunate foresight to do was they have been really mindful about centralizing and standardizing on controls platforms. So they chose open protocol controls platforms, Niagara most predominantly, and they have collated all of their data into one central database. So from an analytics, from a technology partner, that's super enticing. Oh wait, you already have gotten the data into one place. You've already ported all of the data here. You have it formatted. You use some standard naming procedures. And so that's super helpful when you're coming to actually deploy analytics for a system. So from a success, they had a strong technology infrastructure, that we are the total maintenance provider. So also as your vendors are coming up to speed on how do they use analytics to enhance their offerings, we got to do that together as a team with our HVAC technicians, our controls technicians, our smart buildings analysts. And that's part of it, right? Vendors are learning this right along with owners, occupiers, and operators. A kind of cool side benefit, not something we were shooting for right off the bat with King County, but because we're connected to all of their facilities now, our average remote fix for them. So helping them, turn things back on after a power outage, anything like that we can do remotely, or changing set points, whatever it may be, that's typically under an hour, oftentimes right around that 20-minute range. So their speed of response has greatly improved. And why do I bring that up? Because as the occupier, you're trying to have a comfortable space, deal with energy events, and that's a cool side benefit of getting connected, as you can get to things faster. One challenge was building types. We had to think of some creative solutions to get the buildings without automation systems connected. So leveraging smart IoT thermostats was how we went about that. And then training across at MacDonald-Miller. I talked about, hey, we're learning along with this client. How do typical workflows that we've been running for 5 years, from dispatching technicians to buildings, responding to customer calls, how do those change as you also have the computer reaching out and asking for help itself? So that's where I'll wrap on the King County Library System side. It's been a super fun journey for us. And then I'll pivot over to where Joe and I've been playing. So here we go. Come on. There we go. So Joe and I worked, this is one building, large building, 1 million+ square feet. And I can talk about the role that I played, and then Joe can share with you the role he's been playing. And so service provider from an HVAC perspective, that's how we got tied in, but really specifically for this site, only was providing analytic services and some consulting around how to partner with the utility to get your projects funded. And then Joe can talk about a little bit of the setup of how that building was getting taken care of.
Yeah, thanks, Reid. So there was a ton of collaboration on this project. As Reid said, they were not the mechanical. we came in as the property management, and actually at that time had third-party the engineering. And I believe the control system had 2 or 3 different iterations of itself in there. And so I don't want to say we meeting it to death, but we had lots of meetings to discuss what was going to be in front of us. And then once we basically turned it on, we had meetings every week to go over the data that was coming back. I want to say the first week we had 4,000 faults come through, which we all knew was not correct, but we basically went through every one of them and looked at it. And I think the savior in this and kind of the takeaway is the chief engineer that was down there is an exceptional chief engineer, knew his building well. And the owner was very supportive of giving him the time to spend on this project. So as building operators and engineers, we typically don't have a space in our schedule for a project like this to come along and be able to just dedicate our time. Although this owner was willing to help make that happen, the other folks on the team were very supportive and picked up in areas where the chief had been working before. We also went as far as integrating the analytics with the work order system that we had. So that when, once we got the faults zeroed down and I want to say real, but accurate, I'll put that term. Then we turned on the integration with the work order system so that the fault would come through and then go right to the chief's cell phone per se and say, okay, we have a failure or a fault. They were able to open it up, look at it, and actually dispatch it to a team member. And then we would go ahead on the work order system, do completion notes, say what happened, and then that would feed back into the analytics. Again, it was a lot of work, a lot of collaboration, and very successful, as you can see on the ROI. It was fun.
I think, Joe, those all super pertinent points, and from our perspective as a technology provider, right? You're coming into, in this case, a very large building. There is different trunks and communication protocols, and that technology infrastructure and the associated documentation. When you think about making an existing building smart, okay, you want to optimize it, you want to help it deliver comfort, you want to help it hit its energy savings, and you want to make sure you're still hitting that financial return for the owner. Part of the biggest barrier is, do people even know what's in this building still? And as facility providers change hands, as buildings sell and change ownership, and you go through different retrofits and technology changes really quickly, you can end up in these situations where you don't know until you plug that system in what is on the other side, unless you have this really well informed chief engineer. In this case we did, but finding the time, changing processes for how do we work, how do we go through and clean this data so that it can be useful in the future, were kind of all valuable lessons learned for us. Specifically in the case of this facility, we partnered or paired, and this is what I was talking about in the beginning. A smart building may not be something where you spend a lot of your money and time on technology. The smartest thing you could do might be do an LED retrofit. So luckily for this owner, we could do both. So a lot of other energy conservation projects were going on at the same time, and taking that holistic look at a building when you think, I want to make it smart, I want to make sure I'm hitting my deliverables, was important, because we were able to pair the deployment of this. And I would expect a lot of the people on the call are in regions where utilities are getting savvy to pay for performance programs. In the greater Seattle region, there's a lot of opportunities there. So we partnered up with the local utility, and essentially we have a 5-year window to generate as much energy savings as possible, and the utility will help fund those projects. So in this case, the analytics cost has been paid back in around 4 times. And so really attractive. You don't always have those financial numbers out there in front of you, but when you do, it's important to jump on those opportunities to help those facilities get the retrofits and the funding, because those opportunities aren't always available, but when they are, important to go get. think, yeah, Joe hit it. Tuning of diagnostics, that was a challenge in this facility, and not having the documentation so you can tune it up front. But if you apply smart people and smart technology to that, it's typically pretty quickly resolved if everyone's engaged.
Great. Thank you both for sharing. Interesting to see, some success stories and also the lessons learned, those challenges. Of course, what I'm seeing, hearing is, again, making sure the staff, those that are actually operating the building, have the resources they need, are able to pass along that knowledge when, those knowledge holders leave the organization. And then also what I'm hearing is that idea that data, you can have all the data you want, it's worthless if you can't. There's a big difference. Someone in one of the earlier sessions said, touched on, there's a big difference between acquiring data and making that data meaningful, right? And so that can be a big challenge and also a big opportunity there. So thank you, really, really fascinating. Good to see some real world examples, and I want to now turn the time over to Craig to also share some examples from his experience, challenges, lessons learned, and I think he's also going to touch on the intersection of smart tech and HVAC lighting with physical security systems as well. So take it away, Craig.
Thank you very much. I don't have any slides. I'm not a slide person, but I wanted to talk through a couple of real world examples that we've run into that really kind of emphasize some key points for everyone to just take note. One of them, we have a customer, it's a great customer portfolio of buildings. They're elated. They did an ESCO job, and they were able to finally get rid of some pneumatic to DDC, and they finally have transparency in their building. A couple other ones, they didn't have any remote access. They had a control system, but they didn't have remote access. So they were able to upgrade their head end to a Niagara open system on the head end. Now they have the ability to have remote access through that head end, and then start to bring their buildings together through their front end Niagara. The interesting thing is they have a certain group of individuals who have all retired just in the past couple of years, and they have a very big gap in their ability for their operations team to perform. And so they've actually implemented analytics on those buildings. They've started with a smaller group, and what they've found is a couple things. And it's been reemphasized over our past with working with customers, is when you implement analytics, the number one thing you have to think about is who's going to manage that data and that information flow, and how are you going to be able to decompose those in terms of taking action. And almost every single customer that tries to do it alone, typically that program, that project fails, and because there's a lot that has to happen with it. And so we've seen success consistently where depending on your level of sophistication, where you're taking off bites at a time. Reid mentioned 4,000, or I think Joe, 4,000 issues coming up. I mean, you're going to get a lot of that. How do you decompose that? So taking chunks of those and working through those, we've seen a lot of success where either service providers that are implementing this, let them hold your hand at first until you're to the point where your process internally works to the point, then you can start to let go and run on your own, walk then run. But when you try to just go at it, it almost always fails. There's a lot of other technologies out there that do black box, black box analytics. Often you still need guidance and someone coming alongside you to kind of work through that. And it's not to sell more services. It's really to help make sure that you're able to be successful And if you're not successful, then it's a lot of money that was wasted. So don't even do it. And so what we typically see for those type of solutions, 2 to 4 year ROI. But whatever that service provider is, let them hold your hand and work with you through that. And you will see success coming out of that. We measure 3 key things when we're doing any kind of analytics, is, energy, buy equipment, and overall occupant comfort, and then maintenance savings. And so you want to be keen in on those, so then you can make your decisions based on each one of those and which one has the best impact. But again, 2 to 4 years depends on, sometimes you get that 1.5 years or 1 year ROI, but it is a faster payback. We've had some really interesting examples though too, when you take a smart building and you try to make it smarter, right? And you bring in analytics and you layer this technology on top and it doesn't meet expectations, and they want to move to something else. You get into a whole situation of, how do I get that data? Do I own that data as a customer and an owner? And so we have a hospital that's going through this exactly right now, where they're trying to decouple from their existing analytics solution and shift over and, bring on another one. And so whenever you bring on a service and a smart building technology, stop and think about what your exit strategy could be, because technology changes. And whatever is being offered today, 3 years, 5 years, 10 years from now, if it's a newer technology, sometimes they get acquired by a company, or they just don't make it, or whatever, right? Or the technology just doesn't quite meet the expectations of what you want. So think about what your off ramp of that technology is. How do you export that data, and how do you have it in a way that you're not spending an enormous amount of time trying to bring it on to a new technology? So whoever that service provider and technology provider is, talk to them about that. We do a lot of physical security, access control, video, intrusion. One thing that was interesting, we just had a customer who had a very antiquated building automation control system, but they had a big issue with vaping. And so they wanted to bring in vape sensors, these really nice IoT vape sensors, and everybody's excited because it's a very cool thing. And but the vape sensors, they couldn't integrate it on the control system very easily. And so they were able to integrate it on the physical security system. And so it just brings to light, what is your mission? What are you trying to achieve? And thinking outside the box of not control system only, it's physical security, your light, you have different pieces of information, but then how do you bring those back together at some level? And so we're working with that customer right now to bring that data back through the security system to the head end for alarms and alerts. And we have another customer that we're actively with, where the physical security, the video now, is smart enough. You can draw a line on that and show how many people go. You can say which way's in, which way's out, and you can show in and out, in and out, in and out. And they have that on all their exterior perimeters. And so now we can get occupancy count, very active, accurate occupancy count. And so we're looking at how we can leverage those technologies more, especially when you have high rises, elevator lobbies, at different points of entry, that can give us even more accurate account for where those individuals are. So don't always think smart building, smart controls, right? Smart building there's a lot of other technologies involved. A big thing today is mobile credentials. If you don't know, you can get you can't really see it, but your, HID access card is deployed on your phone. And so when you deploy it on your phone, now that occupant has the ability to get in and out without having to have a card issued and all the expense associated to that. And almost every access control company is moving in that direction. Well, what does that also do? It starts to enable the ability to put more things on the phone, around HVAC control and lighting control, along with your access control through mobile apps. And so we have some very specific examples of working with customers with some of our providers where it's an app that unifies those. And now the occupant has those components all in one app. And so the biggest thing that's going to drive those mobile credentials. And so think about, however many with your security group, how many cards do you have to issue or keys do you have to issue? And now it can all be done through an email on a credentialing process. And then you can leverage that to start to add on some of the other occupant comfort creature comforts. The last thing I just want to share is a really good example. You can have the smartest building, but it's also the overall parties involved. We just worked on a building that it's a laboratory building. It's very critical environment, all new controls, all IP-based controls, so all Ethernet controllers, so we can get a lot of data in and out. It's got a Niagara head end. There is no Jace, physical Jace, it's just the Niagara head end. We even had an area where they added something late. We were able to use the Wi-Fi on those controllers, pure Wi-Fi, not Zigbee or an Ocean, but Wi-Fi, so that we didn't have to come back after hard lids were put in and try to run wire. So having control systems that can be able to do that. And then we get it all in. Optigo as a cyber secure network managed switch, all of that. But as part of the project, the occupant, or the tenant, I should say, didn't have part of their scope working with property management, so there was remote access. And so a small, less than $15,000 proposal to get remote access, bring some of the old into the new, different things that would really help give transparency of the whole building with some of the old and the new. And they were willing to sit there and pay a service fee every time someone needed to be dispatched. And so the occupant or the tenant was wrapped up in the owner not wanting to pay the property manager to pay for that last little bit. And so you can put all the great stuff in place, but if you don't have ownership buy-in up front, especially for owner tenant type situations, then things can break down and the investments might not be there. And so you really got to get all parties, all stakeholders involved and make sure they're all aware of what is required for these different things. So a simple thing is remote access where we can take care of things. Instead, there is service fees ongoing. And so that's finally come to a conclusion, but it's a good example for all of us to remember what it really takes to bring that stuff together. So
great. Thank you so much, Craig. It's good to hear some, like I said, those real world examples, also some unique examples of how this technology is being employed, and some lessons learned. What I heard was, for one thing, making sure to have an exit strategy with the technologies that you do implement, making sure that you do own the data. I know it's a big concern right now, of course, is the security of your data when implementing these technologies, which can bring up, financial profit and privacy implications and concerns, and as well as the other lesson that I am hearing you say is talking about buy-in. So buy-in not only from the owner, but I would extend that especially to the operators, right, of the building. So you can have all the fancy, sophisticated technology that you want. If the folks in the buildings who are actually running those don't see the need for it or aren't on board, with, really understanding those benefits and seeing those tangibly in their own, daily work, that's going to be potentially a tough road to really seeing those true benefits, right? And so I appreciate all of your presentations so far. I do want to get into a little more of a discussion with everyone at this point. I know we have several questions that have been answered in the Q&A pane, real technical specific questions. So encourage attendees to go check out those questions and responses, and we'll try to get to a couple others. I do want to touch a little more on that workforce kind of question. In part of my role at the Smart Building Center is the training and curriculum manager for the building operator certification. And we of course recognize that, the workforce is key to, training and arming building operators with the tools they need in this ever evolving industry is key. And I also see that as related to this deployment of smart technology. Building operators are now required not only to have mechanical aptitude, but we're seeing their required skill sets diversifying into maybe touching on a little bit of programming, IT, networking, understanding, data analysis, right? And being able to speak the language with their own IT departments, being able to collaborate, because that intersection between IT and OT are becoming so important. And so that skill set is evolving. We really have a workforce development challenge and opportunity, I think, in that. I know in building operations specifically, we're seeing an aging workforce. And so we do have that opportunity. The good news there is that we have a generation of digital natives coming in, right, that are well-versed with technology. And we also have that opportunity that provides an opportunity to really diversify this workforce too. I want to make that point as well. And so I know not only building operations, but it's been mentioned that, you as panelists maybe have, one of you, who was it, Reid, I think mentioned earlier, we need people. We need people to do this work. So I just want to see if any of you have any more comments about, what you're seeing in terms of the workforce, the skill sets that are evolving, that operator buy-in, and what it's going to take to really make these deployments successful on a large-scale basis.
Yeah, so I guess I'll chime in real quick because I have a lot of end users of the systems. And just, first statement is no two buildings are really alike. So that makes it very difficult. Cars are engineered and manufactured, and after the first 50,000 go out the door, they pretty much have it down. And the mechanics, it's a little easier for them to work on. On the buildings, we have different things, even if they're, identical buildings, if the usage isn't the same, they're not identical. So that creates a challenge. We're also seeing, as you said, the aging workforce and those that know mechanically what's happening, and who have probably fought the technology side of it because a flip phone was good enough and don't need a smartphone, are going. And now we have the smartphone generation that don't understand what's behind the flip phone side of the technology, right? And so it's really difficult on our side to, yes, they might have the computer skills and aren't afraid of the screen and touch screen and doing everything, but we've got to teach them what they're turning on and off. At the end of the day, it comes as, it's as simple as a light switch going on and off, and the little dimmer slide switch that we used to have growing up. It's on, off, or it's analog signal. And trying to correlate those two with what's happening out in the space has been a bit of a challenge. I think, in the old days, auto shop and carpentry shop in high school, and hopefully we still have that. And then bringing those folks that like to work with their hands and still use technology is ideal on our side.
Yeah, really, really good point. Really good point. Go ahead.
Yeah, we're seeing a really interesting dynamic where you have some of the individuals who have been in buildings for a long time. They have a hard time adopting, looking at data, trend data, sifting through analytics as well, right? They're used to their graphics, right? They're used to what they've always had. And so the newer technologies are harder for them to adopt. And then you've got this younger generation that they grab onto the technology, but then they start to believe whatever the data says is fact, and they stay behind their laptop or their computer. And so at the end of the day, Reid, great power saving there. But they don't go out and field verify it. They don't understand mechanical systems as much, or the physical systems. And so I think we have to work on training both groups and bringing them both along, and not discount the younger generation understands technology. So then let's put them in this. They've got to be able to understand the foundational systems underneath that, and vice versa.
Yeah,
Yeah.
absolutely. I think there's an expansion of the skill set needed, right? Not a exchange of the skill set needed. Go ahead, Reid. Sorry, I didn't mean to cut you off.
You're good. One way, not regardless of smart building or not, but I've been an iPhone user, and luckily MacDonald-Miller is an iPhone using company for me, so I never had to learn a different phone technology. But if you have an iPhone, you can FaceTime with any other iPhone out there, and we hammer that from the minute we hire a new person. There are smart people at this company that you need to call, and you can show them exactly what you're looking at. And now with Teams, whether you're screen sharing or showing a physical, controller, or, hey, I think this leak is coming from this component. Do you think it's also coming from this component? There's a ton of cool ways with technology that you can expand that knowledge that has been built up in the workforce and get it to people. And I think sometimes that can get lost as there's this constraint on the workforce, if there's not enough people who want to do the work, that then the smart people are too busy to coach and mentor and nurture their understudies. Well, if you're at a scale in your business where you can centralize some of that coaching, mentoring, and teaching with some full-time trainers, or for us with our analytics team, we have full-time people at a desk who've been out in the field for 20 plus years. They can serve 15 different junior techs in a day to help them get studied up. So I would say that's another spot for people to keep looking, is how do we use technology to enhance how we're training, to make it faster for onboarding, so that they get to see cool issues out in the field, but actually get to solve them rather than leaving and having a senior person show up the next day to fix it.
Yeah, and develop training paths based on the needs, right? Custom training paths that can really help support that.
Yeah, all really good points. I like that idea that we can also use technology to disseminate that information to newer folks. We can use that to our advantage, where the folks who've been around a while had to get that experience from going one job at a time in the field, and the options that we have available to us now just kind of accelerate that learning process, and that's valuable. And you're all absolutely correct. These skills are not dispensable, these old school skills, right? And there's no replacement for that, simply that the depth of experience in the field. So really good point. And I want to just pivot now to talking a little bit about kind of that range of existing buildings. So we have we have buildings that have been in operation for decades that may or may not have a BAS or may have a very antiquated BAS. Does that mean we can just come on in with an overlay and make things smarter? We also have, buildings that are newly online. Are they existing because the keys have been turned over? Well, some would argue, yeah, that's an existing building. So I'd love to hear any thoughts you have about kind of that range of considerations for implementing smart tech in older buildings versus newer buildings, the opportunities that may exist with end-of-life equipment and replacement, existing BAS scenarios, et cetera. Any thoughts there?
Yeah, I guess I think I said before, any building that we operate is existing, and our mindset, because it's been turned over to us. Some are old, some are new. Some of the new ones will be outdated as policy pushes on the climate change stuff. And so we're looking at, capital budgets 3, 5, 10 years out on new and old buildings. And where does that money get spent? How is it spent? How do we get some of it, right? So for us, it's every one of the buildings we're in and operate.
I think from the projects we've had, good wins on or hard lessons on, it's typically the same. As you want to look at the playing field and partner with your client and say, hey, if you have $10 to spend today, where are you going to spend $2? Where are you going to spend $4? Where are you going to spend the rest of that? If that was your total budget, because the biggest thing for them could be weather stripping on the doors, and that might help, but that might only cost $500 to do all your doors, and so jumping straight to technology is gonna be painful if that's where you go, because you might find that the 5 recommendations your analytics told you, if you had sat down and asked your chief engineer, said, hey, what are the 5 most important things I do? They might have told you all 5, and then you could have just taken that money you deployed your tech with and spent it. So, and from my standpoint, just partner with your service providers as an owner, as an operator, have good conversations about what's the best thing for your building. And, eventually, in my opinion, that will lead to analytics, but you might have some stopping places on the way there.
Yeah, I mean, infrastructure is, you got a lot of infrastructure in your building with HVAC controls, lighting, security, fire. I mean, and they all have their own life cycles. Again, what are the challenges you're reaching or you're trying to achieve? What type of building do you have that you're trying to work with, whatever the occupants are? But if you take steps towards your investments based on those goals, and you got to really dial that in. Climate change, there's a lot of policies driving some of that. Currently, there's a lot around physical security anymore, that and especially in certain municipalities or cities. But then you also have just occupant comfort. Are you achieving occupant comfort? So you need to prioritize those, and then you can decide how you work on your smart building and where you make those investments. Some of it gets forced, through legislation. Some of it is, technology changes, like mobile apps, and being able to, that generation technology is no longer available. So you have to move from legacy to newer. So you just got to have all that laid out in a 3-5 year plan and work with your providers to help you budget that.
I'll take a slightly different angle on it and talk about the 85% of buildings that don't have any controls, right? And there's a big opportunity there for energy, for climate, for better building management, right? Better comfort. And I guess, we often run into potential clients, right, that are considering a building management system, but they find with more modern technologies, they can, for a much lower cost, get good enough control, right? And it's important, the context, I think, for these buildings, because they're often not being run by a professional team of building engineers, and facility managers are stretched doing lots of different things, right, besides optimizing the building. And they just need something that works, and it has to be affordable because these buildings are small. And there are, I think there's a big opportunity to serve that group. And obviously that's one of the things we're trying to do, but there are other companies out there that are also trying to leverage, really cheap wireless devices, right, with open protocols that can integrate with each other, have open APIs, and you can actually start to build a BMS Lite that's highly functional and highly affordable for these smaller buildings. And I think that's a big opportunity that we should, as just a community, talk more about.
Yeah, interesting. Appreciate that perspective. Thank you. I want to, we're getting a little short on time here. I do want to just look at, we have a question here in the chat that I think is really, really relevant. And we actually have answered, all of the panelists here today have answered several of the questions in the chat, many of them very technical, specific questions, a lot about extensible energies, software, solutions, what is the fail safe, for example, if that layer fails. And then there's also this question I'd like to just leave with, and it was about which data analytics platforms are recommended, or what kinds of things we should look at. I think the answer is there are lots out there, and I really like Craig's answer here in the answer pane, that really what's most important is your service provider that supports your solution. So I want to just see if there's any final parting thoughts along those lines in terms of, again, it was mentioned no one building is the same, and therefore no one solution is going to work for every building. So what are the most important aspects of how you decide on these solutions?
Yeah, the whole idea is, how do you increase your chance for success of meeting your goals? And unless you have a dedicated team that is focused intentionally on that, every day they wake up and put the hat on of making sure that succeeds, it's really hard for you and your team to do their day job while bringing on analytics or technologies or smart building solutions. And so finding the right service provider, whether it's your facility engineering team like Joe's team, or it's a service provider like Reid or at MacDonald-Miller or Long, or if it's a technology provider like Michael's. And so at the end of the day, it's finding that support and then getting that support locked in with the people and the process, because technology is great, but technology changes. What we've been talking about 10 years ago is not the same as 5 years ago, is not the same as today. So technology changes, but more importantly, your people need support, and they need development, they need training, and bringing experts alongside them to help them succeed is absolutely paramount. Otherwise, don't waste your money, don't spend the money, don't make the investment.
Great, really good advice. And I'd love to just hear, with the minute that we have left, from other folks who want to share one top do or don't when implementing a smart building technology upgrade. Keep it short. you got a few seconds. Go.
I'd say do not give up. I think once you start, you need to see it through the end, and it is going to take a lot of effort. But don't be scared when 4,000 faults come across right away. Those will get brought down to a level you can manage.
Thanks, Joe. Any other thoughts?
Pick one or two use cases. If you want vape detection, get that one done. If you want faults, get that one done. Don't try and build the smartest building in the world all at once.
Really apt advice. All right, Michael, any final last moment do's or don'ts?
I second those and avoid proprietary lock-in.
Yeah, also important. Great. Well, I don't see any other questions from the audience. Again, the session was recorded, and we will, if you want to take a moment to browse the answers in the chat, they're in the Q&A pane. There's a lot of good stuff there. Those technical details that you might have about specific technologies. So with that, I think we'll go ahead and wrap up. Thank you so much to all of our panelists. Really good discussion, a lot of good insights you've shared, and really appreciate you taking the time to share your expertise with us today. Check out the rest of the Smart Buildings Exchange programming tomorrow and Wednesday, virtual tomorrow, and then we have a hybrid if you're here in the Seattle area on Wednesday. So looking forward to hearing what else is on tap, and everyone have a wonderful day. Thank you.